Hi everyone, welcome to this video where I'm going to go through the vector equation of a line. This is for Year 11 Maths Specialist. It's Unit 3B. This is the 3B part for the vector equation of a line. So, first of all, there is a difference between the vector and the equation of a line. The vector has a specified length. It's only the line that goes between A and B. What we're going to develop here is an equation for this line that goes through A and B but continues on past A and B. So the equation, that infinitely long line. Okay, so we know in coordinate geometry what the equation of a line is. Y equals mx plus c. We know m is the gradient, we know c is the y-intercept. So in that one there, we know the gradient is -2 and the y-intercept is 3. Okay, the vector equation of a line is different. The vector equation of the line gives us the position vector of any point on the line. So this equation here tells us if I've got an x value, I can tell you the y value, or the other way around. If I tell you a y value, I can give you an x value, not the vector equation of the line. It's quite different. So let me show you how we get this equation. Let's say we've got A and B. What we're going to do is we've got several more points in the line. We're going to call them R1, R2, and R3. And I'm going to show you how you can get the position vectors of those points. All right. So we need an equation for R, which is the position vector of any point on the line. Alright, so how do we get to R1? Well, what I'm going to do is, to get from O to R1, is I'm going to go from O to A first. This is a point on the line that I know. So we'll call that the vector little a. And then I'm going to move from A to R. In this case, A to R is a half of the vector A to B. Okay. So that would give me the position vector of R1. Let's look at R2. R2, to get from O to R2, similarly, I can go from O to A and then from A to R2. And A to R2 looks like it's about double the length of A to B. So I'm going to say that that vector there is 2 times the length of A to B. Okay, what about R3? To get from O to R3, again, I'm going to go from O to A and then from A to R3. Now, how would I get from A to R3? It's definitely not in the direction of A to B. It's going the opposite direction. So I know it's going to be negative. It looks like about -1/3, I guess. So, or no, -1/4. Let's say -1/4. -1/4 the length of A to B. So you can see that's how I can get from O to R3. Now you'll notice that there's a pattern building up here. All of the points on my line I can get just by changing this number in front of the vector from A to B. And that gives us the general equation of the line. Okay, there it is. The general equation of the line is the vector A, and A is the position vector of any point on the line. T is just a constant, which we vary to get different points. And AB is the vector in the direction of the line. So we could have gone from B to A, in fact. So this vector, this is very much not unique. Unlike the equation of a line where it's unique, this equation here can change depending on the point that you choose on the line and the vector in the direction of the line. All we need to do to get the different points is change the value of t. Okay, so t is a scalar and not a vector. Let's, if we look at the vector from A to B is just b minus a, so there's another way of looking at it. And sometimes you might say that we could use the point B. So it's not unique, like I said. Sometimes we'll just see that that vector in the direction of A to B is just called P, or sometimes people call it B. So you might see this equation written a little bit differently from time to time, but it's essentially the same thing. Okay, so there's the vector equation of a line. Let's look at one example. This is the three-dimensional one, so I hope it doesn't freak you out. So we've got this one here, we've got 2 points, A and B. Now we've got 3 dimensions. That's cool. Don't worry about that one. So we've got X, Y, and Z. So the vector in the direction of that line would just be B minus A, which gives us this vector here. So this is the vector in the direction of the line. So here's the equation of the line. We get a point on the line, so we go from the origin to that point, and then we move t lots of this vector in the direction of the line. As I said, to get any point on the line, I just have to vary the value of t. Okay, let's look at the question that is the first question on your handout underneath the heading Vector Equation of a Line. So we're going to find the vector equation of the straight line passing through that point and parallel to that vector. Right. So this is really, really simple if we know how to do it. We know that the vector equation R, and we could just think of that as x and y, okay? The x value on top and the y value on the bottom is equal to, okay, so we need a point on the line. So it's passing through 1, -3, so I'm going to write it like this, plus t times, and it's going parallel to the vector 4, 3, so obviously it's moving in that direction, 4, 3. There you go. That's the vector equation of the line. Simple. Now sometimes we use, instead of t, sometimes we use lambda, sometimes we use mu. That little constant there is up for grabs as to what you call it, but normally t or mu or s or something like that. Okay, find the vector equation of the straight line passing through the same point, and it's passing through that point and another point with a position vector -2 plus j. So if I say A is the point 1, -3, and I say B is the point -2, 1, then I want to know what's the direction this line is going in. So remember this formula here. So -2, 1 minus 1, -3. So that is going to give me, -2 take 1 is -3. 1 take off -3 is 1 plus 3, which is 4. So therefore, the equation of the line is go to a point on the line. Now I've got 2 points to choose from here, so I could choose either one. Doesn't matter. Let's go for -2, 1. New point. And we're going to move t lots in the vector in the direction of the line, -3, 4. There is the vector equation of that line there. Okay, extra page on your notability. If you add an extra page, I've added an extra question here. What is the Cartesian equation of the line in A? So let's just write that out again. The equation of the line was given like this. 1, -3 plus lambda 4, 3. Okay, there are 2 ways of doing this question to get the Cartesian equation. The Cartesian equation is simply the equation that isn't the vector equation, so we've just got x and y's in it. So here's method 1. What you could do is just recognize, see on the top line here, you've got x equals 1 plus 4 lambda, and you've got y equals -3 plus 3 lambda. So you've got 2 equations, 2 unknowns. We want to get rid of the lambdas in there. It's a little bit nasty, but we can do it. From here, we'd say lambda is x minus 1 divided by 4. So in the second equation now, so I've rearranged the first one. Y is -3 plus 3 times x minus 1 divided by 4. It's -3 plus 3x minus 3 divided by 4 times just the top line there by 4. So I've got 4y equals -12 plus 3x minus 3 times everything by 4. So let's tidy this up. Y equals 3/4 x. -12 take off 3 is -15. -15 over 4. So there's our straight line in Cartesian form, in the standard form we're used to seeing it in. A second method that you could use just involves really understanding. I haven't drawn any pictures here yet because I want you to get used to the theory here. But let's just go for a little picture here. This line here is going through the point 1 minus 3, down here somewhere, and it's heading off in the vector 4, 3. So in other words, from that point, we're going across 4 and up 3. This is not accurate. I want to point that out. So there's our line, across 4 and up 3. Now what's the gradient of that line? The gradient must be rise over run, which is 3/4. So we've got the gradient of the line, we've got a point on the line. That point must be 1, -3, that's this one down here. So we can find the equation of the line. The equation of the line is y equals mx plus c. The y coordinate is -3, that comes from this point down here. The gradient is 3/4, and the x value on the line is 1. Okay, So negative 3, take off another 3/4. So negative 12/4, take off 3/4 is negative 15 over 4. So therefore the equation of the line is 3/4 x minus 15 over 4, which is the same as we had before. So there's two ways of finding the Cartesian equation of a line after it's been given in vector form.